time to take ratios and proportions a step farther with similar polygons. So similar polygons means that they are the exact same shape, just different size. So when I say same shape, I mean a square is going to be a square no matter what, but rectangles can be different. An equilateral triangle is going to be an equilateral triangle no matter what. They can have different lengths, but it's still an equilateral triangle, whereas any triangle is not just similar on its own. They have to have some similar characteristics. Those characteristics are the angles must be the exact same, but the sides have to have a same ratio. So for example, if we were to look at this setup right here, we have a 90 and a 50, which means this is going to be 40. Same with this, 90, 50, this is going to be 40. So all three angles are the exact same measure. But if you look at the sides, 8/4, and we look at 10/5, and we look at 6/3, they all reduce to 2. Which means they all have the exact same ratio. The ratio of these two have a 2-to-1 ratio. So that's what it means by having same angles, but the sides have the same ratio. Okay? If you look at the next example here, you have an isosceles and you have a right triangle. Notice you have no angles, no measurements. I mean, we could even say that this is 10, 10, and 6, and we can say that this is 3, 4, 5. It doesn't matter. We can even turn this into an isosceles triangle and say that this is 3, 3, 5. We don't have enough information to say that these angles are the same. We don't know that this is a right angle. We don't know that this is isosceles, even though we could try to make it one. So you have to have enough information to say that they are same angle measures and similar ratio. So this just means it's not similar. And there's your little similar symbol. So that's that. So in order for polygons to be the same, or to be similar, remember, same angle measures for the sides, or for the angles, and the sides have to have the same ratios. So in this next example right here, it says ABC is similar to DEF. So that means all of these things are going to be true. A is going to be congruent to D. B is going to be congruent to E. C is going to be congruent to F. But then the ratios, AB over DE is going to be the exact same ratio as AC over DF, which is going to be the exact same ratio as BC over EF. Okay, so those are all of your similarities. So the next thing that you need to learn about those is called the scale factor, which is basically their similarity ratio. So a scale factor of ABC to DEF, so that means this side goes first. Basically, all you have to do is take some matching pieces. So 12/4 is going to reduce to 3/1. 9/3 is going to reduce to 3/1. And same thing with 18 and 6. So the scale factor is known as 3/1 or 3:1. Okay, that is your scale factor. So let's go look at the next couple examples. Are these guys similar? So the first thing you want to look at is the angles. We have a 90 and a 20, which means no matter what, these guys are going to both be 70. So we have the angles, so that checks out. Now we need to look at ratios. 6/3 is going to be 2:1. 10/4 is not. That's 5:2. So these are not similar because the ratios are not the same. Okay? So you look at the next one really quick and you tell me, are they similar? Well, we know they're rectangles, and we see that we have a 10 and a 4, and this is 5 and 2. So 10/5 is 2:1, and 4:2 is 2:1. So yes, these are similar. Okay? So that's it. You got to look for angles and look for side ratios. So now we're going to get to some problems where we are going to be assuming that they are similar. Okay, I'm telling you that these are similar polygons. So it's finding the value of x, or finding the length of a missing side. So the first thing you want to do is find some matching sides. So x goes to 5, 9 goes to 3, and 6 goes to y. You want to find one where they both have numbers, and those are the bottom pieces. Okay, so that's 9 over 3. That's your scale factor. So your scale factor is going to be 3 to 1 when you reduce it. But for the algebraic part of it, remember, pick one to be your top, or fraction part 1 or 2. I can always just change this to top and bottom, if it helps you. You don't have to write that. So for all your fractions, you're going to have 9 over, and then its corresponding side goes on the bottom of the other one. So 9 over 3 is equal to. And then to find x, we just put x over 5. And to find y, we're going to do 6 over y. Okay? Anything from this triangle goes on the top. Anything from this triangle goes on the bottom. And just remember to look at your corresponding sides. But then to solve them, all you do is you just take your original, and you can reduce this if you want to. So you have 3 over 1 is equal to x over 5. And then you also have 3 over 1 again, but this is equal to 6 over y. And now you cross multiply both of them, like we learned in a previous video. So we're going to have x is equal to 15. And for y, we're going to have 3y is equal to 6, so y is equal to 2. And that's it. You just found it. So you get to try the next one. What is the scale factor first? And then set up a ratio to go find x. Give it a try. So your scale factor is the sides that match that both have numbers. So that would be 4 to 6, which reduces the 2 to 3. Then to find x, you're going to have top and bottom, if it helps you. 4 over 6 is equal to, go back to the first figure, we have x plus 2, which corresponds with 9. And then you just have to cross multiply, so 36 is equal to 6x plus 12. So that's going to give you 6x is equal to 24, so x is equal to 4. All right, and that's it for that example. If you got that right, you're doing pretty good. Last example. Going back to hourglass problems, but this time I made the bottom triangle bigger. You got to remember with parallel lines, you have transversals. So that means this angle is going to be congruent to that angle, this angle is going to be congruent to that angle, and of course your vertical angles are going to be congruent as well. So that means whenever you have this, if the top and bottom are parallel, then that means you are going to have similar triangles. So what if I threw a 6 and an x plus 2, and a 4x plus 4 at you in this example? You can easily do this problem, but you have to remember, since they're parallel, this angle came down here, this angle comes down here. So to set up this ratio, you just have to switch to the other side. So in this case, we're going to have 6 over 4x plus 4 is equal to x over x plus 2. Okay, because of the parallel lines, they just switch with the transversal. It's alternate interior angles. So that means this side comes over on top of this side, and this side's on top of that side. And then you just cross multiply and you do your thing. So 6x plus 12 is equal to 4x squared plus 4x. And bring everything over to the other side. So you're going to have your 4x squared minus 2x minus 12. Factor out a GCF of a 2. Leaving you with 2x squared minus x minus 6. And now you're going to have to think of what numbers will multiply to a negative 6 and multiply to a 2 for this. So this is where you're going to have to use good old-fashioned Batman. So you have negative 12x squared, and that's going to simplify and factor all the way down to 2, 2x plus 3, and x minus 2, leaving you with x is equal to a negative 3 halves and a positive 2. Okay, if you forget how to use Batman, make sure you ask about that when you see me. Now, here's the thing. Can x be a negative length? No. So your only answer is 2. That's it for this video. This is Longo, and I'm out. See you, bye.